Well, hi, and thanks for joining me in my shop here this morning. So at the end of my last session working on this transformer here, I kind of got results that I just was not expecting at all, and I really didn't know how to interpret. So I'm starting today right from that point. I still don't know what the heck is going on with this thing. I'm doing my best to not conclude that there's a wire problem of some sort in these coils. Open circuit or short circuit. Just before I turned the cameras on, I did a little bit of fiddling with another IF transformer I have. I hooked this up to my scope just to verify that my approach isn't crazy. No, it's not crazy. I'm able to see the peak on here and move it around by moving the slugs. What is going on here? Just to review, the secondary coil and capacitor appear to be okay in how things respond on the scope, which you can see on my upper right of the screen there. It's the primary coil that appears to just have there's no influence when you move the slug around. It appears to be no influence anyway. So, maybe I haven't moved the slug enough. Maybe the influence is very minor. I don't know. The capacitor that's built in here, I've disconnected. It's remained disconnected, and I've soldered in, tacked in. Well, I thought I tacked it in, but apparently I didn't. I'm going to tack that guy in there. So we know it's not the capacitor that's involved here. Now, the good news on my soldering iron is the soldering iron temperature measuring thermometer is coming. So when it gets here, I'll be able to put proper tips in here and set up their temperature properly. I'm just waiting for this thermometer to show up. In the meantime, some more chisel soldering here. I think I got it that time. Let's see. Yep. Okay, so there's nothing wrong here now. If what I've done is I've just removed the defective capacitor here, then we should see normal operation of this transformer. I'm a little worried about the lead impedance. I didn't pay any attention to that last time around. So my probe has a switch here. Times 10 times 1. I'll put it on times 10. That's going to raise the impedance of this. It's going to have less effect. I'll hook it up to the secondary side. I know it's a secondary side. I can see the wires traveling up to the top coil, and I saw in the manual the top coil is the secondary side. Okay, scope is set more sensitive. We're just going to start up right where we were. Now the impedance on the end of these wires is very low, 50 ohms. I'm not sure that should really have an effect, but I'm not sure. Let's start there. Here we are. Well, that's a beauty on the oscilloscope. Now I found last time I could move that left and right with the slug on the secondary coil. Yeah, and see it gets much larger towards the left. You get right past, okay? Maybe I should leave that in there for a bit. Now the other one, it would appear as if I can turn the slug all I like and it just has no effect. Okay, watching the scope now very carefully. Oh. watching this very carefully to see if it changes size or position. There we go. Okay, so I'm going to put this right on this line here. Right on the line. Okay, keep turning it in the same direction. Oh, that's the end of the run. That's it? Yeah, never mind that. Yeah, so that's the position, assuming it's the same size. And then all the way in is high enough to start ranging up into this one. If it's the same size. Okay, we're going to jam this guy all the way through here. Oh, let's get the scope set up. Hey, I can use this to position that where I want it. Right on the line. Oh, you know, if I shake this little guy enough, this is going to move. This slug will move on its own. Okay, close enough. A little to the left of the line. Here we go. Oop, almost losing it. So that's the extent of the motion. Wow, if there was any change in the scope, it was minuscule. Minuscule on the graticule. That is pretty hard to explain. Why that just went like that. So let's make some assumptions here that my input impedance here is just so crummy, so low. I've just reduced the Q of this coil, I guess, is what would happen. I have a resistor handy here. This is a fairly small one. This is a 2K resistor. Let's give it a go. What happens if we isolate away a little bit? Right on the line. Well, let's try a bigger resistor. We're going to go a lot bigger. It's a lot bigger. 2 megohms or something like that. Appears to be in the same spot. Look at that. Pick it up by radio transmission just through the air. Same spot. Wow, this isn't helping one bit. What? So shame on me, I have not read the comments on the last 2 videos. I shouldn't say shame on me. There's very valid reasons why I tend to stay away from them. For the most part, I do peek at them now and then, but maybe I got to study them up and see if there's any ideas in there that might help, because I am really floored at this. I mean, well, what am I left to do here? Cut the coil off? I mean, I don't know. That's one more. I don't know. Okay, I'm going to read a bunch of comments. maybe the answer's in there. Maybe you knew all along what's going on here, and I'm going to get filled in shortly. So I'm going to read those comments and come back. Okay, so I've read through the comments. Thank you very much for your thoughtful comments, and a few comments about driving, because I was muttering about some truck following us closely. On that note, look at this. This is a photograph my wife took of the truck. Now, when the truck, when she started to take this photograph, she had to spin around in her seat, of course. I'm sorry it's gone out of focus here. She had to spin around in her seat. And the truck driver could see what was happening, and he fell back. So this is him having fallen back from the rear of my vehicle. Before this photo was taken, His grill was all you could see out of the back of our truck. He was within literally 2 or 3 feet. I'm not kidding you. I've never had anybody get this close. See how close he is here? This wouldn't freak me out. I wouldn't freak out over that. Lots of people do that. I'm talking about a couple of feet. Oh my God, look at that big truck. You know what this reminded me of? This reminded me of a movie I watched a long time ago, a famous movie of, oh, who was it? Denver? Denver is the actor? Like John Denver. Bob Denver? I don't know. Anyway, an actor being chased by a big truck. It's exactly the same sort of thing. Freaking me out. Okay, enough of that. I'm gonna get all off. So from the comments, I can see everybody's headspace is basically in the same place as mine. Some concern about my equipment here and how poorly isolated it is. Same thing I was thinking. Let's see if we can't settle that once and for all. What I'm going to do, because shame on me, I have poked around off camera a bit when I first came in here to quickly see if I could create a resonant point on that screen. No. So this rather complicated looking decade box here, I'm just going to use it as a resistor. I know I've got big wires here. Yes, problems of all sorts, but it is what I have. So we're going to feed the signal from the signal generator through various sized resistors and see what happens. We already got something up there. What's already happened? What do we got this thing set to? So right now this is actually a capacitor, 20 microfarad capacitor. Okay, well, that's kind of corny. What happens if we just snap it to a resistor? Didn't do a thing. Oh, okay. It's hey, what's showing up there on the left? That's kind of interesting. That's a 5 meg resistor in series. No, it isn't. It's a half a 5. It's a 2.5 meg. That's a 5. Look at this. That's a 2. That's not a 2. That's a 2 times. Come on. Sorry, I'm only thinking with half my brain while I'm watching what's happening. I think we got somewhere here. Now I tried isolating with a couple of 1,000 ohms and it didn't seem to make any difference. So man, I just didn't go far enough. Now watch this. This whole thing's going to work. Look at that. Okay, so the one peak is moving. So let's see what we can do with it. Now 450 is here, and this peak's way over here. It's still a mile off because of the capacitor. The other capacitor is still sitting right here. I can just put those back together, and we'll have double the capacitance there. See what that does. Yeah, wow, it really did something, didn't it? Yikes. So what I've done, now I mean I've included this big bundle of wire here, which can't be helpful. But I believe all I did was just connect that capacitor back up in behind there. And it just knocked the wind right out of this thing. You know, I had not removed the original capacitor completely and gone and tested it in any way. I haven't tested it in any way. Is this really connected properly? My influence on my fingers in here. Yes, this is better done with the can on the top, no doubt about it. How about this thing? Now that's interesting. Again, it likes to peak up right in this area here. Always. Yeah, lots of influence from my fingers. I'm really trying to get this thing into the middle. Let me just recenter it just a wee bit. So at this point, we're way off. We're closer to about exactly where it was, where it seems to be stuck. Okay, let's try this. Now we're back to nothing happening. What happened to the two displays? What did I do here? Oh, I put that capacitor back on. Right. So with that capacitor on, nothing's happening. The original capacitor. Nothing happening. Take it off again. Lots more at the same frequency. In my imagination, or is that a lot? Looks like you can see the two peaks there. That's because I moved this by hand. So this is kind of what I expect to see, is two peaks. You see, when they overlap, they transmit a lot more power or energy to the scope. But they're supposed to overlap way out here. So the way out here slug position is quite reasonable on the top. So the lower guy is just not getting anywhere there. So okay, let's make an assumption. The assumption is the coil is shorted somewhere, and we only got some portion of this coil here. Less coil. Less coil means less. You know, the resonant frequency is related to the square root of the squares of the product of the capacitance and the inductance. So more, this just throws me off all the time. So more capacitance or more inductance will shift the resonant frequency in the same direction. Which way is that? I don't know. Okay. So we have a reduction in the inductance here. We need a similar reduction in the capacitance here. This is a 56 pico, wasn't it? So what if we put in less? Yeah, let's try that. So I'm gonna discombobulate. Let's watch what happens. Wait a minute. Why am I not seeing a nice big thing there? Okay, there. I'm gonna pop this capacitor off, and we'll just see what happens. Didn't solder it that well, did I? Maybe I did. Oh yes, and one of the comments I read was, "What are you doing leaving that great big speaker sitting there face up?" Blah. That's waiting for something to drop into it. How true is that comment? So there we are, covered it up. I'm usually pretty careful with speakers, but okay, I got my eye on the scope. Oh my gosh, there we go. That hardly made a difference, did it? What happened? One of the humps disappeared. So what we've been seeing. So I mean, this all makes sense to me too. What we've been seeing the hump from the upper curve. Then I move it back and forth. There it is. There. The lower hump just disappeared way off the screen somewhere. So we want to bring it back and have it show up more in the middle. We can move this one into the middle. So, oh, look at that. What's happening there now? You're saying that's the resonance of the coil by itself? That's the resonance of the coil when all this stuff is hooked up to it. Is it? Of the primary coil. So, you know, I've always kind of thought with just a coil, you know, the resonance is way off on the left, or just a capacitor, it's way off on the right, but you put the two together and they happily come to the middle. But maybe what's really going on is the coil all alone is pretty close to the right capacitance and inductance, but they just couldn't get it there. So to compensate, they added a little wee bit of capacitance and just moved over a little bit. Maybe that's what's going on with these capacitors. They're not bringing this thing in from left field, they're just bringing it in from the 50-yard line, 10-yard line. 10-yard line sounds better. Okay, from the blue line. That would be better. That'd be more Canadian, wouldn't it? So that would mean put a little capacitor here. I wish I had I do have another capacitor decade box. But I just don't think it gets small enough. Let's try it for fun. Yes, for fun. There's an awful lot of wires hooked up to this thing now. I mean, really. That didn't work too well. Yes, it's goofy and clumsy. You know, just because you think things aren't going to work, that's no reason for not trying them. This isn't going to work. Hang on there. Just hang on there, would you? Anything happened? Something did happen. What happened? So I wasn't watching the screen the whole time, of course. Okay, well, that didn't go very well, did it? So I don't know for sure if it's just disappearing off the screen to the left or the right, or if it's yeah, this isn't gonna help. This is dumb. Okay, worth a try. So let's see, it was a 56 that was in there. I think I stuck a 56 reading 47. I stuck a 56 here. Too much if the coil has shrunk. So let's try half of 56. That would be 28. Do I have a 28? I got a 27. 27 here. Here's a 27. Just try making momentary contact. What's happening? It's hard to do this and look at that screen at the same time. Just making contact with one lead makes the oh, it's my finger over here. Oh. Okay. My hand is just influencing this so much. Okay, so I'm gonna broaden out the sweep so it's covering a much higher frequency range here. Let's set that up, and so right now we're starting at 300. Wow, it is pretty big already, isn't it? Take it down to 200 kilohertz. 100. Let's go down to 100 kilohertz. Why not? And then we'll take it up to, it was at 600, 700, 800, oh heavens, 900. Let's go all the way up to 900. That's a huge sweep now. So that's what's going across here. 455, still roughly in the middle. I think it's roughly in the middle. 100 and 900. I only see one peak on there. Oh, there's another one right there. fooling with this one. Okay, I'm gonna move the slug, the primary slug, and see if that's the one. It got less. It went down. It got smaller. It didn't move. Okay. Whoa, what's going on right in the middle now? Hey, wait a minute. That looked like a bingo to me. That's one right in the middle. That's with neither capacitor connected. Huh. I don't think I ever really tried this with no capacitor connected. That's pretty interesting. So we'll move one of them off. And now you can barely see the other one, barely see the primary one. It's right on the money though. Now if I turn this, son of a gun, there it is moving. Well, what exactly have I done here? I put a 10 meg resistor in series with the signal generator. Hold on. Careful now, I'm not applying an awful lot of brain cells to the voice box right at the moment. Okay, let's put this away. Let's get a big fat resistor here. Big fat one. Big fat guy. There's the green, here he is. Mega, wow. He's big, but not so fat. Should have left well enough alone. What did I just do? Brown, black, green. 10 megohms. That's what I have. Well, that's what that box said. Did I read the box right? Or is the box influencing this? If I do that, are we okay? No capacitor. Okay, so I can't see the resonance of the primary until the secondary is sitting on top of it, wherever it may be. Oh, that's the limit there. Looks like it's way down here again. Okay, was this sitting on top of the resonant point of the primary? Maybe. And move the primary and see if we can see then that there's an influence. Watching carefully. Well, I don't know. Bring back the box. Bring back the box. Get this thing working again. What the heck is going on? Well, now that's interesting. So I'm just varying resistance here. and you can see that resonant point's moving around a bit. This is a half of 5 megs. This is 2.5 megohms in series with the lead coming here, bringing the signal generator signal. Look at that. So this slug is at its extreme point now. It's bottoming out, in fact. But it's managed to produce a resonance. This is pretty close to 455. I think, I can't be sure now. This is not adjusted with any accuracy, so probably not actually all that close to 455. Now, so, and if I stick this guy back on, you can just see it jumping to the left there. I screw this back in. So now the thing is moving to the left. So now it's starting from the left. Of course, I don't know that that isn't moving to 455 here the way I'm doing this. Moving it to the left. So it looks like when I add the capacitor, the two peaks that are here and here separate. One shows up over here. Because they're not overlapping now, the efficiency of the transformer is very low. Not a lot of stuff gets to the scope here to see it. What I really want to do, though, is move it the other way. I think this is the primary peak. I want to move it this way. But I want to do it with the slug right at its extreme point. If I put the slug, let's put both slugs into the neutral zone. Is there such a thing? Okay, so we'll assume that's about halfway, and we'll assume that's about. So I would guess that's about the neutral zone there. Secondary here and the primary there, and we don't know what frequency exactly we're at. We're doing a little calibration stuff there. So it looks like when we add capacitance, the primary resonant point moves to the left, further and further away from where we want it. As if there's already too much capacitance just sitting here, without these ones hooked up. Hey, you put a capacitor in series with the coil? Oh my gosh. Except that you can't tune this to 455. Pick a new IF, tune the whole radio up to a new IF, suffer the consequences. Peel off some windings? I don't think so. Supposedly there's less windings here to begin with. Add more windings. Add more windings. What a crazy idea. Solder an extension onto the lead wire here and just wrap a bunch more turns around it. That just sounds so... Yeah, if it were my radio, maybe. I don't know. I'm stuck. Je suis stuck. I need something. I need some juice in my head here. Uh-oh. I read those comments again. Okay, once again I've read through the comments. There's one comment in there I really like, and this was if I had this idea in my head I would have done it right at the start, and that is simply remove the can, get rid of the two capacitors, just get rid of them that are in there, put the can back on. Now the coils are protected, put the whole thing back in the radio, and then continue experimenting with it in the radio with all the wires connected up to it in the radio. So I could remake these capacitors out here on these terminals. They don't have to be inside here. They can be out here. Boy, that's a good idea. I wish that was in my head right at the start. But since I got it right here, right now, and everything is set up, I'm just going to continue like this. But next time around, I think that's a really, really great suggestion. But, you know, I don't expect the next time around. I've never had a IF transformer behave quite like this. And, so I'm really stuck here. I'm really stuck. I could put a capacitor in series with the coil right now, the way this is arranged, in effect. What kind of craziness would that do? So, okay, where are we on the, looking back at that. So yeah, the two of them are lining up right in here, right kind of where you'd want them, right around the 450. No capacitor. You know what I'm going to do? I think I'm going to... Oh, this is tricky business too. Because the can have an influence on this, I'm pretty sure. Where's the can? Let's find out. Now I'm going to bang this thing. So I'm going to pull this right out. Because we still see something on there. Good. So just can coming over with the can. Oop, don't touch anything. Yeah, this is a silly thing to do, but... Now I'm holding the can, but then the can would be grounded on the chassis. Look at that. Just coming on. And interestingly enough, it comes back. So, well, there's no question this can is having an effect, of course. So I think that's the name of the game. We'll cut these two capacitors out, the original out, clean this thing up, put the can back on, operate underneath from now on. Leave the coils alone. You got to try to solve this without doing anything to these coils. So if I do anything to these coils, I might as well just what? Yes, I'm quiet now. So I'm going to take those capacitors out of there. I'll do it all off camera. And put the can on. I'll operate from the outside. I think that's it for today. Today is another fantastic day. And I'm heading out there, outside. Okay, so yes, I didn't go outside. I was working away on the video you've been watching. I'm looking through it too because I'm curious about all the stuff I did and the results. And right at the very end, I kind of get the feeling I'm really close. So rather than do what I said I was going to do, which is to cut away the capacitor, I just left it just as it is. I haven't done anything. And it looks to me, you can look right on the scope right now. In fact, here. This is the secondary peak. The primary peak is right here, and I'm pretty sure I can move it right under here. Why? I don't know what's happened. So what I've got hooked up here? I've got this resistor set very large. No capacitor on the primary whatsoever. And I also changed the sweep. Let's double check the sweep rate. Double check the sweep here. So starting frequency on the sweep is 407. Let me set this very precisely now. So we'll set this to, let's say, we want 455, let's say 430, 15 below, 430. We'll set it to 430. So really zoom in on the 455. 430, very precisely. That's good. 430, and then the stop, 15 above 455, is 470. Very good on the math, Jim. 470. So 470. Just want to get this. If I get this exact, then we know where 450 would be dead center. 455 will be dead center, Jim. Come on. 430. 430. That's 25. That's 25. 30. 25. 25. 60, 80. 480 is where I should be setting this. Okay, not so good on the math. And my dad was a math teacher. Oh my gosh, how do you like that? Okay. Get that guy going. So, if I've done it right, 455 is dead in the middle. Check it out. It looks great. With no capacitance. So maybe that's the deal. Maybe that's the deal. Okay, so I'm doing the primary side of this. Look at that. Oh, you can see it going right through. And you know what? The slug is in the proper position here. Everything has become normal. Everything has become normal. Why? Why? Okay, let's go back. Look at that. That's beautiful. That's fantastic. Oh my gosh. So that's the secret. No capacitor. It's still sitting in there. It's just not hooked up. Why exactly? I can only guess. A reduction in the number of turns in this coil. That a short occurred, and this thing is not. It's got as many turns as it did. Less inductance requires less capacitance. There's some capacitance just here. There's some capacitance everywhere all the time. So there's some here. That's enough. That's what I'm concluding. And I'm thinking this is tuned up to 455. I could pop this back in the radio and it would work. If I move this off to the side, you can see the peak, the primary peak. You can see the way it's displayed on the scope here. The Q is terrible. There, it's really terrible. We can make this a little higher. There, now it looks better. This is the influence of the primary. That's why it's not getting as thin here as here. You see the peak is pretty much right on the money. Assuming this is exactly 455 here in the middle. Now bring the primary peak back. Whoosh, right on top. Bring it back. Not too often you get to move these things this fast. Fantastic. I deem it fixed. Despite my best effort, I appear to have discovered what has to be done to this to make it work. Well, that's a little bit of a better ending than what was going to be on this video. So I'll leave it at this point, and I think the next stage is I'll leave the one capacitor there, the other one I'll just cut it right out. I should just leave it, just leave it, Jim. Put the can back on, put the thing back in the radio, tack up the wires, see what happens. That'll be tomorrow's excitement. Can we put this back together and have it work like it is right now? It appears to be working. Okay, well, thanks a lot. I'm going to feel a little better. I spend my day, a beautiful day outside. They just don't get any better than today. What am I doing in here? What are you doing watching me? Go outside. See you tomorrow.